Welcome everyone. I think this is the last presentation of ETE 2021, or at least one of the last time slots. So my name is Drew DeCarm. I'm a front engineer here at Chariot, and I'm really excited to introduce you to Richard Feldman. So Richard's a prominent figure in the Elm community. He's authored several packages on Elm, and he's also the author of Elm in Action, so you can definitely check that out. So, as someone who writes JavaScript every single day, or at least a superset of it, I'm very excited about Richard's talk. We in the JavaScript in the front end world love chaos and then interrupting things every month or so. So it's going to be particularly interesting to see how he's come to these specific solutions to get to that point. So with that, I'm going to pass it to Richard.
Okay, this is the edges of cutting edge languages. I'm Richard Feldman. So I started out programming with a basic programming language, and sometime after that I moved on to Visual Basic, and sometime after that I moved on to C, C++, Java, stuff like that. And over time I learned a number of different languages, and I started to sort of develop this sort of habit for how I would evaluate languages. It would go something like this. See if this sounds familiar to you. First, I'd look at maybe the paradigms of these languages. So is it, this new language, is it functional? Is it object-oriented? Is it a hybrid? Is it procedural? Look at like the types. Is it dynamically typed, statically typed, gradually typed? I look at the ecosystem, like does it have a lot of packages? Does it have a small number of packages? How high quality are the packages? And then of course, the most important consideration of all, how does it deal with semicolons? So I would take all these factors into account, and eventually I'd sort of build a mental model of like, okay, what's this language about? But over the years, I've developed sort of more and more, experience with different languages. And I've started to appreciate that there's another axis that I never really thought about in the early days. And that is sort of the edges of programming languages. In other words, where does the programming language end and user space begins? So over the course of this talk, I want to sort of talk through some different scenarios that I've run into over the course of my career and how the edges of the languages have sort of affected that, because they turn out to be sort of surprisingly impactful. Some of the languages we're going to talk about are going to be pretty mainstream, probably ones that you're familiar with, like Python, Java, JavaScript. Some of them are going to be more sort of cutting edge. You may not be familiar with these, but we'll go over briefly how they interact with these different edges. So like Dino, Nim, and Dart. Then we're going to talk about one language that almost certainly you haven't heard of, which is called Rock. This is a language that doesn't even have a release yet. You have to build it from source. It's very much a work in progress, but it really has some interesting concepts to do with the edges of programming languages. And it's also something that I and several others have been working on for a couple of years now. So I'm pretty excited to talk about it. Okay. So we're going to break this down into sort of three sections, sort of three different edges of programming languages. So one is I/O, another is memory, and the third one is editing. So let's start out with I/O. So let's say that I have downloaded some code from the internet. I have this question now, should I run that code? Well, back in the early days of the internet, the answer was, yeah, if you want to get a virus. Largely speaking, if you wanted to do anything really interesting, like you wanted to run some program that was actually going to do something that was meaningful or really useful, you generally had to download some compiled C or C++ code. And yeah, one of the things that happened was you could get a virus from that. Early on, the answer to this was antivirus tools, but these days we actually have way, way lower incidences of viruses than we did back then, at least relative to the number of applications being run, in large part because of JavaScript. And in particular, not so much JavaScript, the language in terms of the syntax, the types, or anything like that, but rather because of the language runtime that the browser uses to run JavaScript. So if I'm running JavaScript in the browser, am I all that worried about getting a virus? No, not really. That's generally a pretty safe thing to do. But it's not necessarily clear that that's always true. Like, let's say I've downloaded some JavaScript from the internet and I'm not running it in the browser. I'm thinking about running it from the command line. Should I still run it? Well, let's take a look at this. So here we have, I'm going to open up script.js. And let's say this is something I've downloaded from the internet. And the first line of this is marked as executable, is it's got a hash bang saying, I want to run this with Node.js. That's the language runtime that I'm going to use to execute this script. Now, to prevent sort of cheating, I've got, there's code below all these comments, but we can't see what it's doing. And essentially the reason that I have put this in there is that I want to make sure that we don't have any sort of cheating going on here. We want to make sure that this is actually sort of simulating the experience of downloading something from the internet and potentially being unsure whether it's safe to run. Like, remember, this could have thousands, potentially thousands of lines of code in it. There's really no way when I download something really, really big from the internet that I'm going to scan every single expression to try and see if it's potentially going to give me a virus. At some point, I'm either going to choose to trust it and run it or not. So let's see if that would bite me in this case. I'm going to run script.js, and it says it's doing totally trustworthy things and nothing to worry about. So That's good, I guess, right? Hopefully it didn't give me a virus, but maybe it did. I don't really have any way of knowing that. So let's take a look at a similar file, script.ts. Now, this one, just take my word for it, is doing exactly the same thing as script.js in terms of like the actions that it's performing. Once again, I've hidden these below all these comments, but there's a difference here. This first line is no longer using the Node language runtime, but rather the Deno language runtime, D-E-N-O. So Deno is a programming language that's relatively recent. It was created by the same person who created Node.js. And one of its sort of selling points is the following. When I run script.ts, which is again going to be used using the Deno language runtime, here's what's going to happen. First, it says doing totally trustworthy things, nothing to worry about. And then it says uncaught, permission denied, requires read access to, and then this is my documents folder in my home directory. And then it says rerun with the -- allow -read flag. It's got this line of code here, deno.read your sync into documents. And basically what this is saying is that the language runtime actually prevented this from happening. It's as if I had been running it in the browser. You know, sometimes you're running something in the browser, you've got a prompt that says like, this page wants to access your microphone or do something that requires your permission. Well, that's what Deno does with certain types of IO, such as file system access. So this is sort of protecting me from that. It's basically saying I can download a script from the internet that's untrusted, JavaScript, and run it through Deno rather than Node. And just by switching those language runtimes, now I can have this sort of confidence that that it's going to be not giving me a virus. Now, having said that, I can't get a virus just from having read access to a file. So you know what? I'm going to say, okay, let's go ahead and give this script the permission that it wants. I'm going to give it -- allow -read, and then I'm going to run it again. Okay, so it makes it a little bit further this time. It no longer gives me a read access error on my documents folder. So it is successfully reading all my documents. And now it's got a new permissions error, requires net access to malicious.example.com. Malicious.com, you say. So you want to read all my documents, and then you want to contact malicious.com. Yeah, no thanks. I don't think I'm going to be giving it that allow --net flag. This doesn't seem like a trustworthy script after all. But we can see how, even though they're sort of the same language from a syntax perspective, and granted, Deno and Node do have actually different standard libraries too, this is a totally different experience in terms of the level of trust. So now I want to introduce you to the Rock programming language in a very, very small way, where we're going to do the same kind of example, but instead of script.ts or script.js, we're going to look at script.rock. So here, once again, we can see we've got code below all these comments, but we're not going to get to see what it's doing. It's, spoiler alert, it's doing the same thing as the other two scripts we're doing. But we've got a different first line here, this different hashbang. So this time, instead of using Deno run, we're using rock run. And Rock is a different programming language than JavaScript. Really has nothing to do with JavaScript, except that I'm using all three of them in this demo. And we can see that here we've got this app thing. That's just defining what the name of the executable is going to be. Don't need to worry about that. And then we've got this thing that is actually interesting here, platform sandbox-CLI. So as we're going to see in a second, Rock has this notion of platforms, and this is sort of a first-class concept in the language. And here I've chosen the sandbox-CLI platform, which is the platform that I wrote in user space. And I wrote it just for this demo. So let's actually start off with not sandbox CLI, but unsandboxed CLI, just to see the difference. So here I'm going to run script.rock. And once again, it's just like, doing totally trustworthy things, nothing to worry about, just the same thing as when we ran the Node.js one. But do we really trust it? We got it from the internet. We didn't vet any of it because all the code was below those comments, and who wants to scroll that far? So let's take another look at this, but changing nothing about the code in here. All we're doing is we're just using sandboxed CLI instead of unsandboxed CLI. We're just changing the platform. Same language runtime. It's all just Rock, but we're changing the platform. Let's see what happens. Okay. So here, doing totally trustworthy things, nothing to worry about, but we get a much more, an experience that's much closer to something like we would see in the browser or in Deno. This application wants to read the file, my home directory and then documents. Do you want to allow this? Well, okay, much like before, I figured, hey, just reading the documents into memory, that's not going to give me a virus. It's not going to, send my data off anywhere. So I'll say yes. And then immediately it says, this application wants to make an HTTP request to malicious.com. Do you want to allow this? And the answer to that would be no, and the script exits without getting access to do that. So here we have a case where we were once again able to get this sort of trusted experience. But a reasonable question here is like, well, how trusted really is it? You switch this thing called a platform, but like, couldn't an end user who was writing this script just like do an end run around the platform? I mean, what did that really do under the hood? Was it really as trustworthy as something like Deno, where it's baked into the language runtime? Well, to answer that, let's introduce a new concept, which is platforms and applications. Now, this is a concept in Rock, but first I'm going to talk about it in the more general sense. Like, what do I mean when I say a platform? What do I mean when I say an application? So as an example, I'm going to use Django. So Django is a web framework written in Python. And Django is what I'm going to call an example of a platform. Like a web framework is something I would be considering a platform. So there are many different applications built on top of Django. So Dropbox uses it on their website, so does NASA, so does the Onion. These are all applications built on the Django platform. Another example of a platform that's not a web framework would be Unity, like the Unity game engine. So Unity, is one game engine, and there are many games built on top of it. So Hearthstone, Untitled Goose Game, Monument Valley, these would all be examples of applications built on the Unity platform. So basically talking about a way to sort of categorize things as this sort of foundational layer that you build applications on top of. It's not quite a library, it's not necessarily a framework, but it's in that sort of category of like frameworks and game engines and things like that, where you have many applications being built on top of them. Okay. So Django, as we mentioned, has a Python API. And so if I'm writing my Django app in Dropbox, NASA, or the Onion, that means that I'm just writing Python code. I don't really care what Django is doing under the hood. I know there's this Python API that I work with, but I don't really know or care what's going on behind the scenes. In Unity, that's even more true. So Unity has a C# API. So if I'm writing these games in Unity, I can write them in C#. But under the hood, Django is Python. Unity is actually mostly C++. So the fact that Unity has this C# API is actually like a really nice benefit, because for all the sort of heavy lifting, the really performance intensive graphics stuff, Unity is able to use C++, but as an application author, I don't have to deal with C++. I can just deal with C#, which is a much more pleasant language to work with. I think most people would agree. So how does Rock approach these things? Well, as I mentioned, Rock is a language with a first-class concept of platforms and applications. This is not sort of the whole point of the language. The tagline of the language is a language for making delightful software, but for the purposes of this talk, I'm going to focus on platforms and applications. As I mentioned, Rock is very much a work in progress. There's a handful of people working on it, but it's definitely not ready for prime time or something you should go out and try to use in production. But if you are curious to learn more about the syntax and things like that, we're not really going to talk so much about that in this talk. This is a talk about edges. So if you're curious about more details about it, just check out rocklang.org for more details. Okay, so let's say that I'm an application author in Rock. I want to build a Rock application. Well, unlike Python and unlike C#, the first thing that I do as a Rock application author always is pick a platform. You can't build a Rock application without picking exactly one platform. So I pick my platform. Let's say that I pick, I don't know, unsandbox CLI, like we did in that example. Great. Or I could pick sandbox CLI, also fine. But I have to pick one. Once I pick my platform, then I need to sort of learn that platform's API if I didn't know it already. So let's say that I'm going through my platform and I discover like, oh, this is how you write to a file. This is how you do HTTP requests. Great. But some platforms might not support those things. For example, you might have a platform that's for building database extensions. Maybe it just doesn't support HTTP at all. That's totally fine. So I learned the API that has the sort of platform's domain-specific primitives for whatever that platform's job is going to be. And then finally, hey, cool, now I can build an application on it. Maybe it's going to be a CLI, maybe it's going to be a game, maybe it's going to be user interface like on the desktop, maybe it's going to be a database extension, maybe it's going to be an Nginx extension. All these are examples of potential platforms that people could build, and then applications people could build on top of those. Now, the Rock platform author experience is different. As a Rock platform author, first I got to pick a name for the platform. Sure, maybe I'll call it unsandbox CLI. That's the name I happen to choose for this platform for this demo, but could have called it anything. Could have given it a fun name, but I just gave it a sort of self-descriptive name. Then you have to define an API. So the API always has to be pure Rock code. So application authors are only dealing with Rock code. So that's the API what it has to be in. And then finally, I have to implement what's called the host. And the host is that under the hood part, like the behind the scenes part. I might write that in Rust or in C++ or in Zig, but as a platform author, it's expected that I'm going to use Rock and also one other language that's not Rock to implement the under the hood stuff. And we'll see why that is in a second. So going back to the Django and Unity example, Django is mostly Python under the hood, Python API. Unity, mostly C++ under the hood, C# API. Rock is much more like Unity in that regard with how its platforms work. So let's say I'm making a web server platform. I need to define an API in Rock that Rock application authors will be able to access. But also under the hood, I need to implement sort of the internal guts of that web server in a language like, for example, Rust. Or maybe for sandbox CLI, making a platform for building command line apps, Rock API, but then maybe under the hood is Zig. Could be anything you want. Now you can pick any language that sort of speaks the C API. Okay, now Rock application authors, really importantly, only write Rock code. If I'm an application author, I'm building a Rock application, I'm writing 100% Rock code, and that's it. I'm not dealing with C++, I'm not dealing with Rust. any of that stuff. In fact, I should be able to just only learn Rock and be able to build Rock applications without having to learn any other language to do that. That's sort of the goal. Now, Rock platform authors, on the other hand, they're writing both Rock code as well as lower level code. And importantly, they're the only ones writing lower level code. And we're going to see how this is really important for that trust aspect we're talking about in a second. If I'm trying to write C++ or C# or anything like that as an application author, I can't do it, at least not unless the platform author gives me some way to opt into that. At a language level, only platform authors are allowed to write lower level code like this, which means we can trust applications that were written on top of those platforms because they don't have the ability to do any end runs around whatever permission systems platform authors have implemented. They're trustworthy. So earlier we had this example where I had this unsandboxed CLI platform, but I didn't mention something important about this. Yeah, unsandboxed CLI does have an API and it does define ways to do interacting with the file system and HTTP and all these different IO things. But the thing that I didn't mention is that in Rock, all IO primitives are defined in the platform. The Rock standard library is just data structures. It doesn't have any way to say like, oh, I'm going to go to the Rock standard library and write to the file system or do an HTTP request. No, none of that. It all comes to the platform, which means that the platform is completely in charge of security. The platform is able to define 100% of the IO primitives. And again, application authors can't drop down into a lower level language and sort of sneak around that. There's no way to do it. So when I switched to that sandbox CLI, what I was getting was basically the sandbox CLI is redefining what all the IO primitives are in exactly the same way that Dino does at a language level for Node.js. Except this isn't at the language level. This is in user space. We've just sort of created this new edge that didn't exist before in Rock. By the way, if you're curious, I happen to implement both of these in Rust under the hood, but again, could have picked any language to do it. Okay, so we come back to this concept of the edges of languages and like, where does the language end and user space begin? And we can see that Rock introduces this sort of new edge that really doesn't exist in, as far as I know, any other languages that I'm aware of. So we have the application where application authors write stuff. We have the language. Those are the two normal ones. But in between, we have this sort of new edge that's the platform, which is in Rock is responsible for implementing all IO primitives and some other stuff that we'll see later. So to this question of, is it safe to run this code that I downloaded from the internet? Well, with JavaScript in the browser, with that language runtime, the answer is always yes. With Node, the answer is always no. It's never safe because it can do whatever it wants to your file system. With Dino, the answer is yes, because the Dino language runtime does enforce these permissions the same way that the browser does. But with Rock, when it comes to the language, there is no straightforward answer there. You just have to look to the platform. So with the unsandboxed CLI platform, no, it's not safe to run that. But with the sandbox platform, yeah, it actually is as safe to run that application that I downloaded from the internet without knowing anything about its contents, not being able to see any of its contents. It is as safe to do that on a Rock platform, like the sandbox one, as it is to do it in Dino. It's just not at the language level. It's actually been moved to user space. The real question there is trust. Do I trust that Dino has done a sufficiently good job of protecting me from, zero-day exploits and stuff like that? Do they have any bugs that let people exploit things to give me a virus anyway, despite their best intentions? It's the same thing with the Rock platform. It's just rather than trusting the whole language, you're trusting a particular platform. Okay, so that's IO. Let's talk about memory a little bit. So I work at a company called No Red Ink. We use Haskell. By the way, we're hiring. And we have a bunch of Haskell services in production. Lots and lots of traffic going through these services, especially one of them that millions of users are hitting. And one of the things that we discovered that we wanted recently is, for performance tuning reasons and scaling considerations, we wanted to get better memory observability on our Haskell service. And in Haskell, there are lots of knobs you can twiddle about, the garbage collector and all these things. But as far as like observability, what we discovered is that we didn't quite have something that we wanted to see. And if we wanted to get access to that, we needed to upgrade the language. We needed to upgrade to a new version of GHC, the Haskell compiler, in order to get access to those observability features that we wanted, which is fine. It's a project you can do. But that's worth noting that this is something that is pretty normal, like to find that if you want to get additional insight into your running application, either you need to sort of upgrade your language or maybe drop down into like C debugging tools that are debugging it, like not really the level of the language, but really the underlying bits and bytes that make up your compiled binary. So that was our experience in Haskell, but that's not sort of the most serious consideration I've heard when it comes to running services in production. I have a friend who a number of years ago was working at a Java shop, and they had a very serious problem. I feel glad that I didn't have to deal with this. So Java, as you may know, uses a tracing garbage collector. This is very popular. Java, Go, C#, lots of languages use tracing garbage collectors. And one of the things that happens when you have a tracing garbage collector is periodically it needs to do a trace. It needs to trace through all the allocations and decide which ones of them can be collected. This takes some time. People have been spending a lot of time trying to make these, minimize these garbage collection pauses or GC pauses. But especially back when my friend was working at this company, they really didn't have that together. And they spent a lot of time tuning this thing to try and minimize the pauses as much as they could. Now, of note, these are knobs you can turn in user space. This is not something where you have to like upgrade Java in order to just like change what your garbage collection settings are or like rebuild the language. It's something you can just specify in command line flags and things like that. But the symptoms that they were having were pretty nasty. I mean, this was serious stuff. What would happen is that they would get a certain amount of the services would be running for a certain amount of time, and they would be building up so much garbage that when they finally did a garbage collection pass, it would freeze the server for so long that it would stop responding to health check requests from the load balancer. So the load balancer would say, hey, are you up? And it wouldn't hear back for so long, those requests would time out, thus leading the load balancer to believe that the service was down. It wasn't down, it was just collecting all of its garbage. So the load balancer would kick it out of the pool. This in turn would put more stress on the other servers, which would cause them to also halt for GC pauses. They would get kicked out of the pool and the entire system would have a cascading failure and everything would go down, all because of garbage collection pauses. So avoiding garbage collection pauses, pretty big benefit for web servers if you can, or at least minimizing the collection times, which again, languages are working on. Now in the Swift programming language, you don't have garbage collection pauses to deal with because Swift does not have a tracing garbage collector. It has an automatic reference counting system. Now, automatic reference counting, great, no garbage collection pauses, really predictable, like memory criteria as far as like how much time you spend dealing with memory, really predictable. One of the really nice things about this is that it's really great for UI applications. That's kind of really what you want if you're building a UI application is you don't want any garbage collection pauses. That's really bad for user experience. And in Swift, you don't have to worry about that. The reason that this isn't used on more web servers is that it does have, typically speaking, all else being equal, lower throughput than tracing garbage collection. In other words, if I have a server running for an hour and in one version it's using tracing garbage collection and another version it's using automatic reference counting, it's probably going to be able to get more done in the tracing garbage collection world because it's spending less time on overall memory management. There's sort of less total overhead, even though it's going to have these pauses periodically. So that's why it's not used as much. Now, NIM is an interesting programming language. You may not have heard of NIM. It's a sort of relatively recently developed language compared to some of these others. In NIM, you can choose in user space what automatic memory management strategy you want. You can actually pick, I want automatic reference counting because I'm building a game in NIM. Or you can say, I want tracing garbage collection because I'm building a web server. Or you can even say, I want you to leak memory. I want you to allocate memory, but don't ever bother freeing it, just leak the entire time. Now, this might sound like kind of a joke, like, oh, why would you ever want that? But actually, for short running processes, this can be the best memory management strategy. Because if you think about it, something like a linter, for example, what's it going to do? It's going to run for hopefully less than a second or maybe a couple of seconds. And once it's done, it's going to exit and then it's going to go back to the operating system. So all the memory that it allocated along the way, what's the point in freeing it incrementally? It's just making the whole process take longer when the operating system is going to clean all that up at the end anyway. So yeah, just leak. That way the process will finish as soon as possible and still all the memory will get cleaned up in an appropriate time, namely when that short running process exits. So NIM is an example of a language where you actually get to configure your memory management strategy in user space. Now, this is not necessarily the full story when it comes to memory management strategies. We talked about automatic reference counting, tracing garbage collection, and leaking, but there's another strategy that we haven't talked about, which is arena allocation. Now, if you use the Apache HTTP server and you want to build a custom like HTTP request handler in that, arena allocation is one of the strategies you can use there. Now, arena allocation on paper sounds unbelievable. Here are some of the characteristics of it. It's really, really fast. It's really, really high throughput. There are no garbage collection pauses. So like automatic reference counting, it's no GC pauses ever. Also, it's super, super fast. It's even faster than tracing garbage collectors. And it's super high throughput, even higher throughput than tracing garbage collectors. Like, wow, what's the downside? Well, the downside is that it's domain specific. Basically, the way that arena allocation works, at least in the context of Apache HTTP server, is you've got your request handler, you get an HTTP request comes in, and you say, okay, I want to start processing this thing. So everything that happens in the course of building up the response is all allocated, all the memory for that is allocated in this special region, AKA arena, that's sort of separate from like sort of per request specific. And once the request is done, we've sent the response back. We're like, oh, all that memory that we allocated in this special place, we know all that's garbage. We don't need to do a whole tracing pass to go hunt it down from all over our applications. Like, no, it's all right there. Just go free that once. Boop, done. It's almost as fast as leaking memory in terms of how long it takes to reclaim it. It's one step shy of just letting the system reclaim it all. There's no trace and there's no reference counting. You don't pay for any of that. So why doesn't everybody do this? Well, the problem is that it's domain specific. That works if and only if your memory management system is aware of the fact that this is not just potentially a web server, but literally is a web server and is able to incorporate that memory management into the concept of the logic that actually handles an individual HTTP request. So this is why you don't really see this used more widely than this, even though it, at least on paper, it seems really, really great. The other thing is that, at least in the case of Apache, you're not getting this automatically from a automatically memory managed system. When you're writing arena allocation, you kind of got to be writing C code, which is not really what we want to be doing for most of us writing our backend web applications. Now in Rock, it's a different story. So in Rock, the platform gets to choose the memory management strategy and to configure it and to customize it and sort of mix and match. So you can choose automatic reference counting like Swift if you're making a game in Rock. The platform author, that is, can choose that if you're making a platform for making games. You can even leak if you want, like NIM. And also, the platform author can do arena allocation. If I'm making a Rock platform for web servers, I can do what Apache does in C, but automatically. So the application author just has no care in the world about what's going on. I'm just writing my web application as if it were Django, except instead of Python, I'm writing Rock. And now I get this amazing benefit of, instead of having to wait for garbage collection pauses or deal with lower throughput of automatic reference counting, I get to use this arena allocation strategy. And I didn't have to lift a finger to do it as the application author. The platform took care of that for me, because in Rock, that's a thing that platforms are in charge of. They're also in charge of memory observability. Remember at the beginning, I talked about I work at Red Inc. We use Haskell. Again, we're hiring. and one of the things that we ran into was wanting to increase memory observability. In order to do that, we needed to upgrade our version of the language. Well, in Rock, though, we don't need to do that because the platform is in charge of memory management. We can actually get that just by switching platforms or upgrading our platform. So let's take a look at what that looks like. So here we are. I'm going to clear my screen real quick. I'm going to open another Rock file, memory.rock. So this one, we actually do get to see the code because we're not talking about security anymore. Again, not really going to get into the syntax here, rocklang.org if you want to learn about all that. But here we have a different platform. So previously we had a platform that was about CLI stuff. This one is called memory-basic. And in a second, we're going to switch it to memory-observable. But first, we're going to run it with memory-basic. Quick overview of what this code is doing. So we have our main right here. File name is demo.txt. Basically, we're converting that into a path, and then we're doing writing demo.txt and to standard out. Then we're going to actually write a file named demo.txt, and it's going to say inside of it, hello Philly ETE. And then afterwards, it's going to say successfully wrote to demo.txt. Hopefully, unless there's an error, but there shouldn't be an error. Okay, so let's do that. Rock run, memory.rock. Okay, so it says write to demo.txt, successfully wrote to demo.txt. Let's verify that that actually happened. Yep, hello Philly ETE, great. Okay, now, once again, as is a theme with this talk, we're going to do nothing else other than changing the platform, same exact application code. So I'm going to change it from memory basic to memory observable. Okay, and once again, run memory.rock. And this time we see, not only does it write out writing to demo.txt and successfully wrote to demo.txt, but it's also giving us some metadata about the allocations and deallocations that it was doing along the way. So this is just, I just kind of threw this thing together. So this is just a timestamp in nanoseconds since the epoch. But program just allocated 56 bytes. This program just allocated 27 bytes. This one deallocated some bytes, et cetera, et cetera. So you can see just like the potential here. You can imagine like using this on a web server, and rather than logging this to standard out, which is not that helpful, sending it off to some sort of metrics server where you can see like a graph of allocations and deallocations on a per route basis potentially. Again, this is all just doable in the platform because in Rock, that's where the edge is drawn. Platforms are responsible for this in user space, but in this way that's sort of decoupled from the application author experience. As an application author, I just picked a platform, and this is what I got out of it. Of note, if you're curious, this platform happened to be written in the Zig programming language. Okay, so let's move on to part 3, which is editing. This is sort of the third edge that we're going to talk about. So I mentioned earlier that I started off with the basic programming language, and then I moved on to Visual Basic, and then I moved on to C++ and Java and so forth. But let me go back to Visual Basic for a second, because wow, have I ever not had as much help from an editor as I got from Visual Basic. I mean, not only was this an IDE in the sense of like, okay, it does type checking and this and that and syntax highlighting, all that fun stuff, but look at this. This is a WYSIWYG editor for UIs. I could drag this to make my window bigger. I could resize any of these things. I could drag new widgets in here. I could edit their properties right here, or I could double click on any of them to edit their event handlers. Now, maybe this was because it was like 20 years ago, but I have very fond memories of specifically using this editor. The language, honestly, don't really remember that much. I know it doesn't have a great reputation as a language, but as an editor, wow. I mean, it's been 20 years and I have never used something that I felt gave me as much help as Visual Basic 6 did when I was 10 years old. That seems kind of off. Surely with this much progress in a field of technology, we would be able to do better than something 20 years old. And yet, although in many other ways the editors have improved, in terms of the overall help that I got as a programmer, really have not experienced anything that helped me more. Now, I did move on to sort of more professional, more common tools like Eclipse for Java. I also use like NetBeans and IntelliJ IDEA. Then I, like many people, said, I don't need all this slow IDE stuff. I'm sick of waiting for the cursor to catch up with my fingers when I'm typing. I want something lean and fast, like first TextMate and then Sublime Text. And then I got into Atom and VS Code because they had better plugins than Sublime Text, even though they didn't quite run as fast. And then these days, as you saw earlier, I mostly use Vim with lots of plugins. But it's never escaped me that these language-focused editors, okay, maybe not so much Basic, that was not the most amazing editor in the world, but like Visual Basic, seem to have a higher ceiling on how helpful they can be to the programmer. And all the language agnostic ones, honestly, the delta between each of these is just not that big. They're all pretty much doing the same kind of stuff: syntax highlighting, autocomplete, errors, stuff like that. And really kind of comes down to their plugin ecosystems as to how much help I'm getting from them. But there's more language-focused servers than just the ones I've personally used. So I want to talk about those a little bit. So here's Dr. Racket. This is for the Racket programming language. And already right away, you can see something that you really don't see in language agnostic editors. Here you can see define rocket, and then here's an inline image of a rocket right there in the editor. Like that's kind of a minor thing. This is not like an earth-shattering revelation, but it's something that you don't see very often. And down here in the REPL, I'm calling circle 42. It's actually drawing that circle for me right there in the REPL. I have seen this in things like Jupyter notebooks. Like Jupyter notebooks are all about the interactivity, and they are not language specific. Like Jupyter's name comes from some of the languages that it supports: Julia, Python, and R. But it's definitely something that you don't see in your typical sort of language agnostic editor that's trying to be something like an IDE experience. Take this a step further, a language that you may not be familiar with is called Dart. This is again, a relatively recent programming language, much like Dino and Nim that we talked about before. Dart is a language where the edge between the language and the editor is 0. Dart is the Dart editor. I mean, that's really how you write Dart programs, is in this editor. That's really the only way to do it. Dart is a language that's sort of focused on simplifying infrastructure. That's sort of the pitch, is rather than having to deal with the modern conglomeration of different infrastructure technologies, all you need is Dart. And you've got your editor, your language, your IDE, all of that right in one place. And also infrastructure and deployment, all of this packaged up in one thing. Everything in the language is aware of all these concepts. So that's why you see right here in the editor, these are not from plugins. This is just like the normal Dart editor as HTTP, workers, cron jobs, as well as the typical stuff you'd see like REPLs and functions and so forth. It's even got a special thing just for 404s and has special functionality around turning a 404 into like an actual valid request. So this is an example of where the edge between language and editor is nothing. And there's an even older example of that that's sort of become modernized, which is Smalltalk, the modern version of that being Pharaoh Smalltalk. This is one of the most inspirational programming talks I've ever seen. I highly encourage everyone to watch it. It's called What Functional Programming Can Learn from Smalltalk. And it's basically kind of a demo of like, hey, did you know this was out there? Did you know this is a thing that you could do? And what you're seeing on the screen here is a live demo of a graph of the source code being run in the editor. This is the editor editing the source code, running a graph about the code and like the code metrics. I think it's something like function length or something like that, average function length, inside the editor. If you want to get some sort of like maybe less fancy and wow type stuff, but still like more practical stuff, multiple development is another great talk to check out about sort of all the things that Pharaoh lets you do. what you're seeing here is basically kind of like what we saw in Dr. Racket, where you're seeing representations of code that are actually tailored to what that code actually is. Like, so here we've got some code for a math formula, but it's actually being represented as a math formula. It's being rendered that way. Here we have like a color that's being represented as RGB, HSL, HSV, the different ways to see that color. Again, all of this is like right there in the editor. So when I kind of zoom out and think about like language focused versus language agnostic editors, the obvious downside of a language focused editor is that it only works for one language. But there's a lot of upside there too. I mean, I know that like by volume, programmers these days tend to use language agnostic editors, but I cannot deny the fact that the ceiling on how much an editor can help you is way higher over here. I mean, yeah, like plugins are great, but just imagine what else is possible. Which brings me to my final demo of the day for Rock, which is the Rock editor in all of its glory. Just kidding, it's not actually that glorious because it's very, very early days. The other stuff that I showed you, that all works. The editor, much earlier stages than the rest of the language, but we are shipping an editor with Rock, and this is what we've got so far. So I'm just gonna demo you kind of to give you a sense of what we built so far. So I'm gonna start by opening a curly brace, and you see that the caret moves actually in between it and closes the curly brace for me. Now, I know a lot of editors have this. This is not a particularly impressive feat, but I want to pause on this for a second because in most editors, you're editing a text buffer, and what happened there is that it inserted a space character after the open curly, a space character after the caret, put the caret in between, and then close the curly brace. This is not a text buffer. Rock is a structured editor, or the Rock editor is a structured editor. So basically, what I'm editing here is actually like an in-memory AST of the actual program that I'm going to be running. Rock doesn't actually have a textual format as far as a text buffer in the editor. It's just going to save it to a text buffer on the disk, which is why, you know, we saw previously I was editing Rock code in Vim. So you can use whatever editor you want in theory, but the goal is to make this editor so nice that nobody would really want to use another editor, hopefully. I know there will be some Emacs people who are like, I will never use anything but Emacs, but the goal is to make an editor that's so great that you will want to switch. Okay, so I've opened a curly brace. I'm making a record here. So I'm going to say conference, colon. And as soon as I press the colon, it adds a space for me and then puts this little block in here, basically saying, like, wait, you need to put something in here. You can't just have a dangling colon with nothing after it. One of the goals here, again, very early days, but we're hoping to rule out, if not all, hopefully all syntax errors by doing this, like making it so that you can't accidentally make a syntax error in the editor. So we've got this little block here that's saying like, okay, this is a blank, you need to fill in the blank with something. Well, I'm going to fill in the blank with another record because that's fun. I'm going to say name colon, and this time I'm going to actually put a string in there. I'm going to say ETE exclamation point. Great. So another thing you can do in the Rock editor is, again, because this is like a structured editor and it has a first-class concept of the abstract syntax tree. Usually when I'm working in another editor, a common thing that I want to do is I want to select the surrounding expression. Like I don't really care about like word in the editor sense, like a word. I don't want to go to a word boundary. If I'm inside a string literal, sure, but very often what I want is I want to select the expression surrounding what I'm in right now. So we can do that in the Rock editor. I'm going to Command Shift up, and it selects the surrounding expression, namely the string that I was in. You can also see that it's using type inference to print the type that it inferred right above this. So this string literal, it correctly figured out as a string. You know, yay, good job. That's not a particularly hard one, but if I press Command Shift up again to expand the selection to the enclosing expression once more, now we can see, okay, it inferred that this is a record which has a field called name, and that field's type is string. Cool. And of course, I can do it one more time to expand the expression all the way out. And now we can see the full type of this record, conference, which has a record inside of it, which has name, which has string. Now, I mentioned earlier, kind of in passing, but Rock is a language with 100% type inference, which means two things. One is that it can do type inference for every type in a Rock program. There is no Rock code that you can write where the type inference system will fail to infer the type or where it'll get it wrong. So it always gets the correct type, and it always is able to infer it successfully. This is not true of many languages, but it is true of Rock. So very reliable type inference. The other thing to note about this is that, again, this is, by the way, the end of the demo. This is all we've got so far. And like when I say this is all we've got, what I mean is like literally an hour before I started talking, Anton just finished this feature and pushed it on GitHub. So shout out to Anton for getting that in just in the nick of time so we could demo it. And also a bunch of people collaborated on that feature. So it's not just Anton, but he did it in the nick of time. Anyway, so this editor is something that we're taking great pains to make sure that it's really, really fast. So what you're seeing here is not Electron, it is cross-platform, but this is going straight to the graphics card. I mean, we are really like, we're using WGPU RS, if you're curious, written in Rust. And so it's really just like, we're doing all the text editing ourselves. It's going straight from the AST, straight to the renderer. And we've done a lot of stuff to performance optimize this already. And we're just getting started. So basically, our goal is to have a lightning fast editor that's just really an absolute joy to use, and which has a lot of features that I can't demo yet, but which I can at least talk about in terms of what we have planned. So let's talk about that briefly. This right here is a sort of mock-up demo. You can sort of imagine that this is something that we want to have in the future. So imagine that I type star equals and then powerup.init. So I'm making a game, I'm using a game platform. So we like the editor to sort of print in gray, like, hey, this is the argument that this thing takes. So that then I can press tab and it will just jump me into this first blank here and say, okay, I need to give a name to this power up. And the type of that is going to be a string. So great, I'll type in star. Then I'm going to press tab again and go down to the ability. And ability, this could autocomplete because maybe there's a fixed number of options here. So I'm going to say, okay, this is going to have the invincible ability, this power up. And then finally for the image, let's say I do image.url and then this string here. Now we saw previously in Dr. Racket, that Dr. Racket was able to actually show the images in line. And that's something that we'd like to be able to do as well in Rock. But rather than doing it at the language level, we want to do this at sort of the editor plugin level. Like this is something that you can build as an extension to the editor. But of course, this being Rock, we don't want to just assume that it's safe for any plugin to arbitrarily access your file system. And in fact, the goal is to design the editor to be a platform and the plugins to be applications. So we can do that same kind of permissions thing that we did that's completely trustworthy that we saw earlier on with the command line stuff, but in the editor. Such that when I put this in here, maybe this is the first time I've used this plugin and I get something like this. It says, hey, this plugin wants to read from star.png, is that okay? So again, we can have the same kind of browser-like experience where you have these granular permissions. And I can, on a per plugin basis, say, yeah, this is okay, that's not okay, and make sure that I'm not having to worry about these plugins running sort of arbitrary code that might potentially give me a virus or worse. And that turns out to be a very important consideration because of one other thing that we want to do with these, which is that we actually don't want to make it so that these plugins are things you have to install separately. The goal is to make it so that these are plugins that you get just from installing the package. So when I do this, I just by virtue of the fact that I'm either using this particular platform or maybe I'm using some image specific package that goes with this platform, just by the fact that I installed that package, I want to just get this user experience where I just get the star rendered in my editor without having to install something separate at all. I just get the code, and culturally, we want to make it be a thing that when you're making a package, not only do you make the code and the documentation, but you also make editor plugins to go with it. Imagine the tooling experience you could have if you had an entire ecosystem that was built around that idea. Seems like it has a lot of potential. Well, let's keep going with this example. So we've got our star in here, but this is a game platform, and games typically don't want to load one individual file for every single graphic they have. They usually want to do what's called a sprite sheet, where you have one file that has a whole bunch of images in it, and then you do sort of sub-coordinates within that image to sort of cut out the individual images that you want out of that to reduce the number of file loads you have to do. So let's say we have sprite.fromSheet, and we're passing in some sort of sprite sheet here, and it's got the coordinates of this particular image, so 0, 0, 32, 32, which is this rocket, but we want to change it to a star. So let's say that we are able to click on this, and then it brings up sort of the entire sprite sheet. Usually a sprite sheet's much bigger than this, but for this demo, this mock-up, we'll just pretend it's 4 elements here. I want to just be able to click on the star and have it do bidirectional editing, which is to say, this plugin says, oh, I know you clicked on the star. I want to go and actually rewrite the code that corresponds to this to update those values inside the sprite sheet, such that I can do editing either by typing into my editor or through the plugins. This is something you might see Sketch and Sketch with, like Ravi Chugg has done some great demos on this. Check them out on YouTube. And why stop there? I mean, why have something, only small things like this plugin? Why not have like an entire chart? Something like, again, you only find really in Jupyter Notebooks. Why does that have to be a third-party tool? Why can't we just get that experience as part of our editor? And again, not because we installed some separate plugin, just because I installed a charting package. When I install a charting package, why shouldn't I just get this experience right here in the editor? And furthermore, why stop there? Why not have interactive things that are, not just like hover over the chart, but, imagine entire workflows for stepping through algorithms. And now we're getting into Brett Victor territory and these types of things. So putting all this together, maybe this helps understand why we've designed this editor to be, number one, really, really fast. And number two, a structured editor where the concept of the language that is being edited and the code in there is a first-class thing in the editor. Again, if you're interested in any of these things, we're very open to and friendly people when it comes to accepting contributors. So please feel to check out rocklang.org if any of this is exciting for you. Okay, so to summarize, we talked about sort of three broad categories of edges of programming language. So we talked about I/O, memory, and editing. And we talked about some mainstream languages like Python, Java, and JavaScript, and how you could like tune and tweak them in some cases in user space, but quite often needing to stay in the language space. We also talked about some cutting edge languages that draw these edges in different places like Dino, Nim, and Dark. And finally, we talked about Rock, which is at this point, as of 2021, still a work in progress. We also talked about different ways to look at languages other than these sort of edges. Talked about paradigms. If you're curious, by the way, Rock is a functional programming language. It has full type inference like we talked about, so statically type checked. The ecosystem is non-existent, but we aspire to have it be maybe the first, at least I don't know of any others, where you have the concept of packages and editor plugins together. And finally, semicolons, Rock doesn't have them. Okay, so then we talked about the concept of platforms and applications. We talked about Django being an example of a web framework, which is a type of platform, and there are many applications built on that. Talked about Unity being another example of a platform. It's a game engine. Many games are written on that, so those are applications built on that platform. We talked about how Django has a Python API and mostly Python under the hood, whereas Unity has C# API and C++ under the hood, mostly. And Rock is more on the Unity side of things, where you have this Rock API that's public facing so that Rock application authors only need to know about Rock code. They don't need to get into Rust or Zig or C++ or anything. But under the hood, you can still use those higher performance language to, number one, implement all your I/O primitives, because platforms are exclusively in charge of implementing I/O, and also for performance benefits. Okay, then we also talked about the scenario of I've downloaded some code from the internet, should I run it? We talked about how sort of traditionally, this is something that really the answer to this question always lies in the language runtime. This is where that edge is. In JavaScript, if you're using a language runtime in the browser, it is trustworthy. If you're using Node, not to be trusted. But if you're using Dino, it is trustworthy. Whereas in Rock, that question sort of shifted. It's no longer a question of the language because the Rock standard library only has data structures. It's not capable of doing anything that could potentially harm your system. That's a question for the platform. Do you trust this platform is the new sort of, do you trust this language in the cases of these other languages, or do you trust the runtime? Then we also talked about memory management and how it's not really a one-size-fits-all thing. It sort of varies by use case what you want. Like web servers would really love to do arena allocation, but since that's not automatic memory management, at least not traditionally, usually you end up with a tracing garbage collector as the most popular. Whereas graphical UIs are, Arc can be a better choice because there's no chance of a GC pause and the lower throughput isn't necessarily noticeable by the user. Short-running programs like linters and things might actually just benefit from leaking, and Nim is a language that lets you configure between leaking, Arc, that is automatic reference counting, or tracing GC. And Rock is a language that lets you choose between, at least at the platform level, the platform author can choose, I want automatic reference counting, or I want to leak, or I want to use arena allocation. And as far as I know, this is the first language that actually lets you do automatic arena allocation, which for me is a very exciting prospect. We talked about memory observability and how we demoed this like memory.rock file that originally just printed out, writing to demo.txt, successfully wrote to it, and then we switched to a more observability-friendly platform that, in addition to doing that, also logged all this information about the allocations and deallocations it was doing. Again, you can imagine on a server wanting to have this get sent off to some sort of logging system rather than printed the standard out. And finally, we talked about editors and how there's language-focused and language-agnostic editors. Language agnostic editors, it's really all about the plugins as far as how much help you're going to get, but the ceiling on how much help you can get is much higher for the language focused ones. And again, Rock's goal is to be a language where the editor and the plugin ecosystem are the same as the package ecosystem. You can just get plugins automatically just by virtue of adding packages to your project. We went through a demo of this with the sprite sheet, and of course, finally with the graph, a sort of like more advanced example. Okay. So finally, bringing this all together, I'm sure many of you are familiar with evaluating languages based on paradigms, types, ecosystem, and of course, semicolons. But hopefully this talk has given you some insight into some relevant ways that you can evaluate languages differently in terms of their edges and answering the question, where does the language end and user space begin? Thanks very much.
All right. Thank you, Richard. That was definitely interesting. It's I don't think there's really any questions right now. You're getting some applause for sure. What can we do? So you mentioned rockline.org for sorry, Martin's got a question coming up. So you mentioned rockline.org for the website, correct? Is there
yes.
Is there anybody that we can follow, or anybody that you know of that we can sort of stay up on what's happening with Rock, or where Rock is going?
Sure. I mean, you can follow me on Twitter. There's also Rock_Lang on Twitter, but I just own that account and very rarely tweet from it at this point. I mean, to be honest, it's, on the website, there's some links to some other videos, and it's going to be quite a while before we're ready for like even an 0.1 release. Like right now, it's all you got to build it from source and stuff like that, because we really want to do a good job with it. But if people want to be brave and build from source, like it is something that you can try out today if you want to.
Sure. Great. So it's kind of like, Dino in its really early stages where they said, hey, here's this thing, this is coming, but it might be a little bit until they've got it.
Yeah, exactly. Yeah. Cool. That type of thing.
All right. So yeah, if anybody has any questions, feel free to post it in the Room C Slack. And then if you don't have access to Slack, you can post it in the Zoom chat. All right, so Martin asked, you mentioned a long history of programming language experience. So I'm guessing that you got a chance to develop an application for Windows 3.1 back in the day. Do you look back in that era in horror when you talk about intentionally leaking memory? Quote, because the OS will clean it up anyway?
Oh, I mean, so when I think about intentionally leaking memory, so first of all, I have definitely unintentionally leaked memory when I've written like C and C++ code back in the day. But as far as intentionally doing it, I mean, as far as I know, I only know of two like somewhat well-known applications that do this on purpose, which are LLD, the linker, and the D programming language compiler, both of which do that strategy. So as far as the strategy to use, I would certainly only recommend it if you know it's going to be a short running process. Run it, then it exits, no user input along the way. But as far as like, have I done that myself? I actually have not personally. The Rock compiler actually does do that strategy only if you're running like a batch build, like from start to finish. You see like Rock build, it will actually do that that same like leaking strategy, because why not? It actually is pretty good if you have a short running process. But other than that, I don't have any like personal experience from doing it back in the day.
Great. So what were some of your main motivations for starting the project?
Main motivations for starting the project. Yeah, I talked about this in one of the videos that's on rocklang.org, but I guess the short version is that I'm a big fan of the Elm programming language. I actually just realized I got my Elm radio mug right here. It's been like an absolute joy for me to use. Elm is a very domain-focused language. It's like for building web applications like in the front end. That's what it's for. But I kept running into all these use cases where I was like, man, I want to build a like Vim plugin, or I want to build a database, or I want to build a web server, I want to build a command line app, or I want to build a desktop like GUI app. And I kept saying like, what's the best tool for doing that? And the answer was always not Elm, because Elm doesn't do that. So what I really wanted was I wanted something that sort of felt like Elm and tried to capture the feeling of using Elm, but which I could use for all these different domains. And one of the things that I think Elm does really well is by having this really focused sort of core where the only primitives available to you in Elm are the ones that are for that domain. And so I wanted to try and think, how could I generalize this such that for any given domain that I went into, whether it was like graphics, UIs, or command line apps, or web servers, or whatever, I could still get that really focused core that just only has the primitives that make sense in that domain. That was where the idea of platforms came from. And then I don't know, the more I iterated on it, the more I realized that it had a lot of potential that I really hadn't anticipated when I started out.
Excellent. So we have another question from Mike. What is the history? So how did Rock come to value security at the platform level? So you mentioned D now, which is new. Are there any other languages trying to address this problem as well?
Are there other languages trying to address this problem? Almost certainly, but I don't necessarily know what they are. Like, honestly, I actually think that this is a really underrated part of why JavaScript got popular. One of the things I've noticed that happens when a new language comes out is people say, well, obviously you need to have some way to access the existing ecosystem of like, pre-existing languages. Like you got to have interop with some more popular language. Otherwise, how can you possibly keep up? And I always think that this is funny because one of the examples people will say is like, oh, like for Elm, for example, people say like, oh, you need JavaScript interop in Elm, and Elm does have JavaScript interop, but in order to be able to access this wide ecosystem of millions of JavaScript libraries. What's funny to me is that JavaScript didn't do that. JavaScript did not say, you have C interop in JavaScript. And if it did, I don't think it would have gotten as successful as it did, because then it would not be true that you could visit a website and run JavaScript and be confident that it won't give you a virus, because C can certainly give you a virus. The fact that when you run JavaScript in the browser, it's not able to access all those primitives that like existing languages, like when it came out in 1995, had, is where its whole security model comes from. And I think that's a really underrated aspect of how JavaScript got as big as it did. And it turned out, yeah, people just ported the ecosystem. They built a new ecosystem, and that whole ecosystem is, at least in the browser, is totally secure. So to me, that actually, like, believe it or not, JavaScript itself, like the original JavaScript in the browser, was one of the main exciting things to me that was sort of like motivating the security story. I was like, how can we get a programming language that is running things, and actually like the editor plugins was the real motivation there. Like I wanted to make sure, like, if we're going to build this editor experience, how can we be absolutely certain that when I get an editor plugin automatically, just because I install this package, they don't have to worry that, like, should I install this package, or am I maybe going to get a virus from the, you know, the plugin that comes with it? And that sort of the security idea came from. Then I realized, oh wait, that's not just useful in editors, that's useful everywhere. So that was kind of where it came from.
All right. Another question from Vic. Is rock compiled AOT, compiled GIT, interpreted, or something else?
Ahead of time. So rock uses LLVM as a backend. We also have a development backend in progress that's intended to be like faster and capable of hot reloading and stuff like that. But that's very much in the works and not up to feature parity. Everything you saw just now was the LLVM backend. So if you're not familiar with LLVM, it basically generates machine code that's like really highly optimized. So if you notice, when I ran the rock program, and it was like, hey, I need to like, well, when it was like, when I was running the rock scripts, it was doing rock run. It was compiling everything ahead of time and doing all the type checking and then doing the LLVM output. And actually it was also rebuilding the platform, which is not always something it's going to do, but right now it does that. So almost all the time that it took to run that was waiting for LLVM or waiting for the platform to rebuild. The actual like rock compiler, although it is ahead of time, in terms of like type checking and parsing and all that good stuff, it's so far it's very fast. I don't have like exact benchmarks to give because like the longest rock program in existence is like a couple hundred lines of code probably. Yeah, we're designing it to be ahead of time compiled, but very, very fast.
Awesome. Mike Smith actually asked the question. I just missed it. Do you guys have a GitHub? Is it private? Is it public? Do you plan on open sourcing it?
Yes, we do have a GitHub. It is private at the moment, but if you want to get access to it, just email me at rock@rtfeldman.com and I'll give you access to it. The whole reason that it's private is basically that we're trying to grow the language intentionally slowly rather than virally. We know that we're not ready to have a whole flood of users, so we're trying to like use some strategies to like get the word out, but not have it like explode in terms of interest. We want to get like sort of a trickle of interest and like just like incrementally grow. And then eventually we'll be like, okay, now we're ready to like do a proper release. Let's put it out there. Let's open up the repo. It is open source, permissive license, you know, the whole usual thing you would expect from a programming language. The unusual thing is that we're intentionally trying to only grow it sort of slowly and incrementally and not virally yet. And set really clear expectations about, you know, it's not ready, it's not ready.
Yeah, it makes perfect sense. So what was that email again, one more time?
Oh, just rock, like ROC @rtfeldman.com. So my Twitter name, .com.
Okay, cool. There was a question about that.
Yeah, just email me and say like, hey, I'm interested in the rock repo, and I'll send you an invite.
Sweet. Definitely very compelling, extremely compelling, especially
Thanks.
what Dina's been doing with the runtime, and definitely all their permission concerns.
Yeah, it's funny, when I'd actually already like started designing rock, but I don't think I'd started implementing it yet. Like the first line of code was the January 2019, but I saw the talk about Dino and I was like, this is familiar to me.
Yeah, that's awesome.
But yeah, it made for like a great like example that I could demo of, you know, like just the trade-offs of like doing it at the platform versus doing it at the language level.
Yeah, it's a great compare and contrast for sure. I mean, it's got to feel good to see that you were on kind of the right path.
Yeah.
All right. Does anybody have any more questions for Richard? I don't see any more. All right. So it looks like we've got all of them. So,
Awesome.
Richard, I sent you the Slack. So if you want to join in, it's room C on the Slack. If there's any more questions.
Sounds good.
With that, thank you so much for joining. We really appreciate it. That was a very nice presentation.
Thanks so much for having me. Appreciate it.
All right. Take it easy.
Take care.
Bye, everyone.